Alright, in this video we're going to look at box plots, which are sometimes also known as box and whisker plots. If you look down at this example of a box plot down here, you can see why they're also known as box and whisker plots, because you've got a box and on either side you've got a whisker, kind of like on a cat. Okay, what are box and whisker plots or box plots? Well, they're another way of showing data graphically, showing a bunch of data, a bunch of numbers with a picture. In the same way that we've seen these other types of pictorial or graphical representations of data, such as stem and leaf plots, histograms, polygons. The box and whisker plot is another way of showing data graphically, which makes it easier to see what's happening in the data than if you just got a list of numbers. But the advantage of a box and whisker plot or the difference over these other ones rather, is that in a box and whisker plot, it allows you to see where the data is bunched up, where it's concentrated, and where it's spread thin. It allows you to see those things a bit more easily. Okay, let's look at how a box and whisker plot is constructed. Okay, first of all, we need some data that we can look at. Okay, here's some data. Now, in order to make the box and whisker plot, we need 5 pieces of information. Okay, it's called the 5-figure summary, or 5-number summary. The 5 numbers that we need for the 5-number summary are the minimum score, the maximum score, the median score, Q1, which is the median of the lower half of the data, and Q3, which is the median of the upper half of the data. If you imagine that this box here contained was a set of data, then the minimum would be the lowest number, or the lowest part of the data set. The maximum would be the highest part of the data set. The median would be the middle number in the list. Q1 would be the middle of the lower half of the list, and Q3 would be the middle of the upper half of the list. Now, although in this picture each quarter looks to be about the same size, as we'll see, when we actually look at real data sets, that won't always be the case. Alright, let's do the 5-number summary for our data set up the top of the screen here. The minimum value. Well, our numbers are in order already, so it's very easy to find the minimum value. Here it is on the end, number 3. The maximum value is at the other end because the data is ordered, so that's 42. The median value. Okay, to find the median value, we use this little equation. The number of scores in the list plus 1 divided by 2. That will be the place in the list where we'll find the median value. Okay, there's 14 numbers in this list. So when we work that out, we find that the median is the 7.5th value in the list. So 1, 2, 3, 4, 5, 6, 7. And halfway between the 7th and 8th is 7.5. So right here is where the median value is found, in between 22 and 26. So the first thing to note is that since our median value falls between these two numbers, we've got a nice neat split in our data. Below that split will be the lower half of the data, and above that split will be the upper half of the data. If the median had have fallen on top of a number, then that number would be crossed out and it wouldn't be in the upper or the lower half, but we've got a nice split in between two values. Okay, to find the median, we have to average out these two numbers, 22 and 26. It's been done here. 22 plus 26 divided by 2 equals 24. So 24 is the median of the whole data set, which is also known as Q2. Now we've only got to find Q1 and Q3. Q1 is the median of the lower half. So if we look at the lower half of data, we've got 4, 5, 6, 7 values. So using that equation from earlier, 7 plus 1 divided by 2 equals 4. We're looking for the 4th number in the list, 1, 2, 3, 4. So 12 is Q1. And in the upper half of the data, we're going to have the same number of values. So it's again going to be the 4th number in the upper half, in the upper list, 1, 2, 3, 4. So Q3 is 35. Now that we've got our 5-figure summary, minimum 3, maximum 42, median or Q2 is 24, Q1 is 12, and Q3 is 35. Now that we've got those values, we've got everything we need to construct our box plot. Okay, so here's our data up here in the corner, and we're going to put our box plot here. The first thing we need to put down is a scale against which we can measure our box plot. So here's a scale, and notice that on the scale the lowest value I've got is just below the minimum value, and the highest value on my scale is just above the maximum value. I need to make sure that my scale can encompass all the values that are in my data set. So I've constructed it so that it does that. Okay, now all I've got to do is mark each of these points from the 5-number summary on my scale. So the first one's a 3, so I'm going to put a little mark about here for the 3. Next one is Q1, which is 12, so I estimate 12 to be a little about here, just before the halfway point between 10 and 15. Q2, 24, so just before 25. Q3 is 35, so that one's just under there. And the maximum is 42, which I estimate to be just here. Okay, now for my box and whisker plot, this is the first whisker from the minimum to Q1. This is the other whisker from the maximum to Q3. And the box stretches all the way from Q1 to Q3. And Q2 is a line that goes down the middle of the box, or wherever the Q2 is in the box, marking the median. Okay, so that's a kind of ugly looking box and whisker plot, but I think you get the idea. On the end of each whisker, we'll just put a little dot to clearly mark that position. And we've done it. We've created a box and whisker plot. Okay, now a couple of things to highlight about the box and whisker plot. The first is we always need to have a scale alongside the box and whisker plot. Otherwise, it doesn't tell us anything. It doesn't mean anything. It needs to have numbers attached to it. And those numbers need to be chosen by you as you create the box and whisker plot so that they're appropriate to the data in your data set. The second thing is, from this box and whisker plot, we can note two important values. One is the range. We can see from the box and whisker plot what the range is, because it'll be from the minimum to the maximum value. It'll be that distance. We can also see the interquartile range, which will be from Q1 to Q3. So, and the third thing is the median, which we can get from the box and whisker plot. So just with this picture, we can tell a whole lot of information about this data set. So if I didn't have all my numbers to tell me what the 5-number summary is, I could get it from looking at this box and whisker plot. I can look at it and I can say, okay, the minimum value, it's got to be around here. There's 5, it's just under 5. So the minimum value is about 3. I can see from the box and whisker plot. The maximum, I can see, well, there would be 42.5. It's just below that. It's about 42. So I've got the maximum from looking at the box and whisker plot. The median seems to be just below 25, so it must be, median is Q2, so it must be 24. The Q1 looks to be just below 13, so Q1 must be 12. Looking at this, Q3 looks to be just below 35, so Q3 is 35. I can get all that information from looking at this box and whisker plot, and this one's not that well drawn either. Okay, let's look at some common types of box plots, some common examples that you'll see. Okay, the first one here, this is a normally distributed box plot. Okay, the data has a normal distribution. If it was graphed, it would look like this. On a graph, the same data set would look something like this. It's called normal distribution because it's so common. You've got most of the scores in the data grouped around the middle, which would be around the mean. Okay, most of the scores are close to the mean, which is what you would expect for something like height. Most people have around an average height. But there's always a few people that are very much below the average and a few very much above the average, but most are around there. Well, we see the same thing in this box plot here. we see that the interquartile range, the gap from Q1 to Q3, is much smaller than the range as an overall. Okay, so 2/4 or half of the scores are in this rather tightly clustered area, whereas the lower quarter and the upper quarter of scores are spread out over a much larger area. Okay, that tells us most of the scores, half of the scores, are around the mean, and the other half of the scores are spread out over a much wider range. That's a normal distribution pattern that you expect for lots of different data sets. Okay, now compare the normal distribution, which I've placed up here, with a different box plot. This one's of what we would call a clustered distribution. Okay, clustered because, similar to the normal distribution, a lot of the data is close to the mean, but in this case it's much more extreme. A whole half of the data is very, very tightly packed close to the mean here in the box, between Q1 and Q3. A whole half of the scores are in that tiny little range. Okay, whereas the lower quarter and the upper quarter are spread out over a very wide area. Again, if we saw a graph, a polygon graph of that kind of distribution, it would look something like this. Very tightly clustered, a lot of the scores there, and when you get to very low or very high, you find it's much less frequent. Okay, now a third common type of box plot is when you've got spread data, which is kind of like the opposite of clustered data. Here's what that looks like. So that's what a spread box plot would look like. In this case, we've got the middle 2/4 from Q1 to Q3, or the interquartile range. It's spread over a very wide area. So the scores, the half scores that are in this middle quarter are spread over a wide area, as opposed to the clustered data, where all those scores were packed very close to the mean. In this case, there's plenty of scores away from the mean. And here's what that would look like as a graph. Okay, the last two common types of box and whisker plots that we're going to look at are positively skewed and negatively skewed. Okay, we see positively skewed, the box plot is slanted towards the left. The box is over to the left, and so is the median to the left of the left side of the box. It's no longer in the middle. It's a little bit over to that side. The far left whisker is shorter than the right hand whisker. That's a positively skewed box and whisker plot. A negatively skewed box and whisker plot is the opposite. The box is down the right hand end, and the median is down the right hand end of the box. The right hand whisker is shorter, and the left hand whisker is longer. That's a negatively skewed set of data. So a lot of the data is tilted towards the right hand end in the negatively skewed, and a lot of the data is tilted towards the left hand end in the positively skewed box and whisker plot. Okay, an extra point to make about box and whisker plots is that sometimes in a data set you have what are referred to as extreme values. Values that are so remote from any of the other values in the list that they don't really fit in, and they can kind of misrepresent or slant the data in a particular direction. So rather than put those into our box and whisker plot and kind of misrepresent what the data really looks like, we can mark extreme values off to the side with a little X, and that way the box and whisker plot doesn't end up having this really long arm, which gives a false impression that there's all kinds of data points in between these ones and this one. There aren't. So it's better to put that off to the side. It's either called an extreme value or an outlier. Now there are ways to determine which values constitute an outlier and which ones don't. So how big does the gap have to be before it becomes an outlier? But for the moment, we'll just say that if we estimate that there's a big gap between any value, either below or above the normal data set, then we can decide for ourselves that we can call that an outlier. Okay, here's a summary of what we've looked at about box plots, which you can pause and copy down if you like. Thanks very much for watching the video.